All right, class, here is section 4.3, synthetic division and long division. So maybe you remember from your algebra classes about long division. We are going to review it today, and then we're going to find out that many times, instead of long division, we can actually use a very nice shortcut, which is called synthetic division. So we're gearing up towards, we've seen in the previous sections that if you have a polynomial function that is nicely factored out for you, then you can easily graph the function by using those intercepts and then weaving your graph through. Now, what if we do not have those nice factors, right? So the idea in the next sections is going to be, how do we get to these nice factors of a polynomial, right? So how do we factor a polynomial? And synthetic division is going to have a lot to do with it. It's going to be very helpful, so that's why we're practicing it. Okay, so here it is. Let's say that we are given this polynomial, f of x is x cubed minus 15x squared plus 75x and minus 125. And we would like to factor it. And then let's say somehow we would know that x equals to 5 is a zero of this function. How could I find the rest of them? Okay, so you will actually have to do such problems in the next couple sections. Okay, so we know that if x equals to 0, our zero factor theorem says that if x is a 0, then if 5 is a 0, then x minus 5 is a factor, right? So that's what we played with a lot in 4.2. So therefore, f of x can be written as an x minus 5 times something else, right? And it's this something else that we would like to find. So let me take you a little bit on the side and remind you of things that you have learned with just numbers. So let's say in elementary school, you've learned to factor 30. So you had to think about what numbers multiply to 30. And maybe you might say, oh, 5 times 6. Yes, that's what gives me 30. Great. 5 has no other factors but 1 and 5. However, 6 can be factored out further into 2 times 3. Okay, so therefore we know that 30 is a 5 times a 2 times a 3. Really, in any order, multiplication is commutative. Yes. So therefore, again, if you would have thought, oh, 30 is 3 times 10, great. 3 has no other factors but 1 in itself. However, 10 can be broken into a 2 times 5. So therefore, 30 is a 3 times 2 times 5. So the same 3 factors, the order doesn't matter, right? So that's exactly what we're going to try to do with polynomials, right? Chip away one factor at a time. So the question is, maybe it comes naturally to you to think, oh, 30 is 5 times 6 without really thinking, oh, 30 is 5 times, let me think about this other number. So let me start with maybe something a little less familiar, 28. Not 28. Let's try 58, I meant. Even worse, 58. So it's not one of those things that might come out of the multiplication table. So you might think, okay, what goes into 58? So what kind of factors does 58 have? So hopefully you're thinking, hey, 58 is an even number, so therefore for sure 2 must go into 58. Now the question is, what's the other factor? So now you take your calculator and you take 58 and divide it by 2. And when you do that, your calculator is going to say 29, right? So these are your 2 factors. And by the way, 29 cannot be broken up anymore. So what I'm trying to get at is that we do the same thing with polynomials. So for example, why did you think that this 5 was chosen to be a 0 for this polynomial? Because really what we're going to do is look at this last number there. And we're going to, same as we looked at that last digit of 58, right? And we saw it's even. This 125 definitely has 5 as one of its factors. Actually, 125 is 5 to the power of 3. It's just 5 times 5 times 5. So the only factor you could really have is 5, or 1, by the way, but yes. So that's why we picked 5. Now the question is, if I have this x minus 5 as a factor, how do I find the rest? Well, I must divide x minus 5 out of x cubed minus 15x squared plus 75x and minus 125. Okay, so to figure out the rest of it, yes, the rest of it, I have to divide, right, and find the remaining factor. Okay, so this is where long division comes into play. And so what you've learned is that you write the x minus 5 at the front. Then inside here we write x cubed minus 15x squared plus 75x and minus 125. So it works just like a division between numbers. Let's say I'd need to divide 15 into 1575. Yes, then you just put, that's the setup, right? So just like a division of numbers, when we do this, we have to think of these terms 2 by 2. So I'm looking at how many times do these two terms go into these two terms. And of course, what I'm doing is I'm just guiding myself by the first terms only. So this is what I'm saying. If you try to divide 15 into, let's say, 1793, you're not looking at the whole number as a whole, but you're thinking 15 goes into 17 about as how many times? Well, just as many times as 1 goes into 1, which is 1 time. Yes, so the same thing here. So how many times does x go into x cubed? So we're simply performing that division only. So we're taking, we have an x cubed, and we have an x, and we need to get to x cubed. X goes into x cubed, then x squared times. So what we simply do is subtract these exponents, right? Because again, x cubed is an x times x times x. And then one of the factors of x goes away, and you're left with x squared, right? So that's the answer here, okay? So I'm multiplying it back out. X squared times x is x cubed. X squared times negative 5 is negative 5x squared. And what very much should happen is that these terms better be lined up. So what I mean is you only can subtract like terms, so therefore add like terms. And the nice thing is that these are like terms. So now we're going to subtract, but be very careful. You're not just subtracting the x cubed. You have to subtract this whole polynomial. So therefore, all signs have to be changed. So you get a negative x cubed and minus 5x squared. So that turns into a plus. So there you go. These front terms cross out because x cubed minus x cubed is nothing. Negative 15x squared plus 5x squared is negative 10x squared. And just like in any other division, we move on by bringing down the next digit, in this case, the next term. Okay. All right, and now we play the game again. How many times does x minus 5 go into these two terms? Well, I'm just going to look at the first digits only. So x goes into negative 10x squared how many times? Well, I need a negative 10 factor, right? And then another x. And I also would like you to notice how these powers go down by 1. Okay. So here it is. Let's multiply. Negative 10x times x is negative 10x squared. So these two have to match. Then you know you've found the right factor. Negative 10x times negative 5 is positive 50x. And then again, we're going to go and subtract. So minus minus is a plus, and then minus a positive, that's a minus. So subtracting, again, negative 10x squared plus 10x squared is gone. And then 75x minus 50x is 25x. And now bring down the last term, kind of like the last digit of the division. And play the game again. Okay. How many times does x go into 25x? Okay. That would be just 25 times, right? So that's the factor that we're missing. Yes, 25. So 25 times x is the 25x that we needed. 25 times negative 5 is negative 125. So hopefully you guys see, even without switching signs, and why it is important that we switch signs, because yes, 25x minus 125, subtract 25x minus 125, you get a 0, right? So we also know that if the remainder is 0, that means the division, or this x minus 5, is a complete factor. It goes in evenly. Yes, there's no remainder left. So the answer is going to be an x squared minus 10x plus 25. So that's what goes in here. So really, the point again of the whole story is to chip away at this polynomial right here. Okay, find all its factors. So we knew that 5 is a 0, therefore x minus 5 is a factor. And when we factored it out, I took a linear factor away. Now I have a quadratic, which, by the way, again, factoring is so important because now we keep using it. So we already know, and we're going to keep using it, how to further factor this quadratic. Okay, we know how to factor quadratics like this. In other words, we're going to think about what? X squared comes from an x and an x. And numbers that multiply to 25 and add to 10 are, by the way, another minus 5 and minus 5. So yeah, kind of like the 125 was a 5 cubed. This whole polynomial in the end is an x minus 5 quantity cubed. So the x minus 5 was really the only factor that the polynomial had. So again, that's how we will complete the problems coming up in the next sections. For now, we're just practicing on this division part, as we will need to keep dividing over and over again in order to find the remaining factors. Okay. Now, since we have to keep dividing, this process takes a long time, okay? And it's not easy. It's definitely difficult. So here it is. Synthetic division is a shortcut for long division, so we could use synthetic division instead of long division, but we can only use it when dividing by factors of the form x minus some number or x plus some number. Okay, again, it's really x minus a negative turns into a positive, but here I wrote it so you could see them both. And that's exactly great, because that's exactly the kind of factors we would be dividing by anyhow, right? Because again, if 2 is a 0, then x minus 2 is what we divide by. If negative 2 is a 0, then x minus minus 2 is what would be dividing by. Okay, so anyways, it's the kind of divisions that we would perform anyways for this purpose of finding zeros of polynomials. Okay, so let's redo this problem and I'll show you how synthetic division works. Okay, so I'm going to set it up the same way. In other words, the division setup. Inside here, I'm supposed to write my x cubed minus 15x squared plus 75x and minus 125. However, we will only write the coefficients. That saves us a lot of time. And the reason why we only write the coefficients, because these are really the ones that we're looking for that come up with the numbers that we need, and you'll see it. Now, for this, absolutely these terms have to be in descending order. You have to know we only can just go by the coefficients because we know this is the guy for x cubed, this is the guy for x squared, this is the guy for x, and this is the guy for no x. Same way, if I put an ordered pair 1, 7, I know for sure that that stands for x and that stands for y. I can't mix them up and still assume the first one's x and the second one's y if I don't apply the rule that they have to always be in this order, right? So they have to be in descending order. And also, if you are missing a term, as we'll see in the next examples, you must fit them in with 0 coefficients. All right, so for now, here it is. They're all in order, 3, 2, 1, none. And then I put the coefficients out. Here at the front, we are just going to write the number 5. So I'm not writing x minus 5 or 1 minus 5. I am going to take this number here and I'm going to change its sign. So instead of putting minus 5, I am going to change the sign, because see how every single time instead of adding we had to subtract and we had to change the signs over and over again. This is why we changed the sign from the beginning. So instead of minus 5, we put a plus 5. And therefore, we won't have to subtract, but we're going to have to add. So you will see how nicely this works. Now, I will leave yourself one row of space and put a bar. And synthetic division works by first bringing down this number 1. Okay. Then take the 1, multiply by 5, and write it in the space to the right. And then, again, because we switched the signs already, we add. So we'll get negative 10. And so I just want you to look a little bit up above and see that that's exactly what we had. We had a negative 15 added to a positive 5 that gave me the negative 10. Okay. Then redo the problem. Take now the negative 10, multiply it to 5, and write it in the next space over. That's negative 50. And add up the two numbers. So again, I want you to see how I had a positive 75 minus 50, giving me 25. Yeah, so I don't have to switch the signs. It's already coming with the correct signs now because we switched the negative 5 to 5. And then finally, again, take 25, multiply it to 5, and you get 125. Add them up, you get a 0. Now, this number at the back is always the remainder of the division. Okay. These numbers here at the front are the coefficients of the quotient. Coefficients of the quotient. Okay. I knew something was wrong. There's an E here. Coefficient. Okay. Okay. All right, so in other words, the quotient of this division is The 25 is the no x, the 10 is the x, and the 1 is the 1 for x squared. So my quotient is x squared minus 10x plus 25. So the last number is always the one with no x, right? And then going up, x, and then x squared, right? You also should know that we're getting a quadratic as the highest exponent because we're dividing a third degree polynomial by a first degree polynomial. So x goes into x to the third, 3 minus 1, so x squared. So it's always 1 less than the degree of our dividend, and that's the polynomial that you're dividing out. Okay. So let's try this one more time. That's all pretty much we're doing in this section. Practicing on synthetic division. So here it is. Now at the front, put the opposite of this number, so -2. Inside, put the coefficients of these terms. So it starts with a 2x to the fourth. Now immediately as you see, there is no x cubed. Therefore, we put a 0 for its coefficient. The reason why there's no x cubed is because we have 0 of them. So you do have to fill in the missing terms with their coefficients. Same thing as, let's say, you want to take the number 2095 and divide by 12, whatever it is. You cannot just not write the 0, yes, and just write 295, because then I'm going to think of a whole different number. Okay, so you need to make sure that we have the spacing going and we account. If we don't put the 0, then I'm going to think that's a no x, x squared, and that stands for the x cubed. But I don't have an x cubed, I have an x to the fourth. So the point is, if you have missing terms, you have to fill in their 0 coefficients. Okay. Leave some space and put a bar. Start by bringing down the 2. 2 times -2 is -4. Add them up. -4 times -2 is +8. Add them up. 5 times -2 is -10. Add them up. -5 times -2 is a +10. Add them up. Okay. So 11 is the remainder of this division. Okay. So let's see how we would write the answer. Now again, you're taking a fourth degree, dividing it by a first degree. 4 minus 1 is 3. So in other words, we're starting with a 2x cubed minus 4x squared plus 5x and minus 5. Perfect. So no x, x squared, x cubed. What do I do about the 11? How do I write 11? Well, I'm not going to write plus 11 because then that means I actually should have a +6 at the end, and it didn't go in 6 times. So again, kind of think like here. If 3 goes into 8, let's just pick something easy. 3 goes into 8 2 times, yes, that's a 6. And then when you minus it, there's a remainder of 2. So how do we write this division? 8 divided by 3 is equal to what? 2. But then there's a 2 left over. And don't write R2. That's a little bit too easy, I'm just going to say. But what we're saying is that there is a 2 left over to be divided by 3. It's just too small, yes. Now, of course, over the years, 2 plus 2/3 turned into 2 and 2/3. So for this, we are going to just add, oops, here it is. So I'm at the end, and now I have to write the remainder. So 11 is left over to be divided by this x minus 2 is just too small to finish the division. So that's how you write the remainder. That 11, this is how many times it goes in evenly, plus there's an 11 left over, still to be divided by x plus 2. All right, so let's try this again. Now at the front, I'm going to put a -4. Inside, I'm going to put a 1 for the x cubed, no x squared, no x. So there's an x squared is missing. The x to the 1 is missing. So that's why we have 0 for both those places. Leave some space, bring down the 1. 1 times -4 is -4. Add them up. -4 times -4 is 16. Add them up. 16 times -4 is -64. Add them up. So we have a 0 remainder. Our quotient is x squared, so 3 minus 1, starting with x squared, minus 4x plus 16. And there it is. And there's no the 0 left over to be divided by x plus 4, but 0 over that, there's just 0. Okay. And let's do this again. Now, 3/2 is definitely a possible 0 that we're going to be looking at next. For the purpose of synthetic division, it might be helpful to write 1.5. If you don't like fractions, it can easily be done with the fraction 3/2. But if you don't like it and you'd rather use 1.5 with your calculator, then no problem. Okay, so here I'll go with 1.5. Sorry. Okay. Now in here, I'm going to write all the coefficients. So I have a 2x cubed, an 8x squared, a -10x, and a +3. So I wasn't missing any terms. Leave some space, bring down the 2. 2 times 1.5 is 3. Add them up, that's 11. 11 times 1.5 is 16.5. Add them up, 6.5. 6.5 times 1.5 is 9.75. Add them up, that's 12.75. So again, that's the remainder. Okay. So here is again my quotient and the remainder. So we'll get a 2x squared plus 11x plus 6.5. That's the end of it. Plus, there's 12.75 remaining to be divided by this x minus 3/2. And if you want to change it all to decimals, because again, we've been using decimals instead of the fraction and it kind of looks more consistent, then there you go. All right, so here's just one more. And you guys can try it. So the number we'll put at the front is the opposite of -1, so +1. Now be very careful. I tricked you in several ways here. Make sure your polynomial is in order of exponents. So my first term, the highest exponent, the one that gives us the degree, is 3x to the 5th. Now, I don't see an x to the 4th. But the next one that I need is the 2x cubed. So they have to come in order. X to the 5th, x to the 4th, x to the 3rd. The next one should be x squared. I don't see any of them. The next one should be x. I see -9. And then the next one should be no x. And I see a +5. You have to have them all, including the no x. So if you're actually missing the +5, the no x, you would have to fill it in also with a 0. Okay, it has to have all powers up to the no power or the 0 power. Okay. So leave some space, bring down the 3. 3 times 1 is 3, add them up. 3 times 1 is 3, add them up. 5 times 1 is 5, add them up. 5 times 1 is 5, add them up. -4 times 1 is -4, add them up. Easy, very fast. Oops. Okay, so my answer is going to be a 3x to the what power? 5 minus 1 is 4, plus 3x to the third, plus 5x plus squared, plus 5x minus 4, plus 1 is left over to be divided by x minus 1, but that's the end. So again, the remainder has to be written over the quotient. That's what's left over to be divided, but it's just too small. Okay. All right. So synthetic division we'll get to practice over and over in the next couple sections. It works very nice and very fast. We don't need to keep track of the x cubed, the x to the fourth, whatever. We just write the coefficients and then we're filling in our x's at the end. So I put on a couple more long division problems. So remember, synthetic division can only be used when we divide by a binomial of the form x minus some number or x plus some number. In any other case, we must use long division. We can't use the shortcut, okay? So sometimes we might actually need to do these kind of divisions. So here it is. I'm practicing only on what we might need in the next couple sections, not just random type of long division. So here it is. Okay, so I'm going to write the 2x minus 3 at the front times, or divided into 6x cubed plus x squared minus 13x and minus 3. So again, remember, when you start the division, you're looking at the first terms only. So to go from how many times does 2x go into 6x cubed? Well, 2 goes into 6 3 times, and to go from x to x cubed, we need an x squared. Okay, now take this number and multiply it to both. 3x squared times 2x is 6x cubed. 3x squared times 3 is -9x squared. And again, see how nicely the powers are lined up, the x cubes and the x squares. It has to be that way so you can combine like terms. So these 6x cubes go away. The 1x squared plus 9x squared is the 10x squared. Bring down -13x. And do the same thing again. Think about how many times does 2x go into 10x squared? Well, we need a 5 to go from 2 to 10. And we need one more x factor to go from x to x squared. So 5x times 2x is 10x squared. 5x times -3 is -15x. Subtract. Again, when you subtract, you change both signs. So the 10x squares go away, and -13x plus 15x is 2x. Bring down the -3. And now again, you're looking at how many times does 2x go into 2x? Well, there's no secret, that's a 1. So 1 times 2x is 2x. 1 times -3 is -3. And of course, when we subtract these, we get no remainder. So therefore, the answer is just that. No remainder needed. And again, I also want you to point or to notice how the powers always go down by 1. So we divided a cubic by a first degree. Of course, we're getting a second degree, 3 minus 1. And then second power, first power, 0 power, right? All right, here's another one. So I do have an x to the fourth minus 3x cubed minus 3x squared minus 3x and minus 4 to be divided. And I want you to pay attention and make sure you have all the powers, right? No term is missing. But as you see, there is a term missing in the quotient, in the divisor. So therefore, it has to be also added in. So you need to have every digit of this polynomial, every power accounted for, whether you just write the coefficients down or all the terms. But to do the long division or to do any division, you need to have every space accounted for. So there's no x, therefore we put in a 0. Okay. So here it is. I'm guiding myself just by the first terms. So to go from x squared to x to the fourth, I need an x squared, right? 4 minus 2 is 2 more x factors I need. So x squared times x squared is x to the fourth. X squared times 0x. I know it's a 0, but I'm going to write a 0x cubed. X squared times 1 is 1x squared. So the reason why I wrote the x cubed is, again, for you to see how these powers are nicely lined up and why I needed that. So I can account for every term and I can have nice like terms to put together. So again, when I minus it, this becomes a minus, this becomes a minus, and this becomes a minus. I have to change all the signs. So x to the fourth minus x to the fourth is 0. Negative 3x cubed minus 0x cubed is negative 3x cubed. Negative 3x squared minus x squared, 1x squared is negative 4 of those. Bring down one more term and play the game again. How many times does x squared go into negative 3x cubed? So I need a negative 3 factor and one more x. Negative 3x times x squared is negative 3x cubed. Negative 3x times 0x is 0 or plus 0x squared. Negative 3x times 1 is negative 3x. Okay. Subtract them. In other words, change all these signs. Okay. So, negative 3x cubed plus 3x cubed is nothing. Negative 4x squared minus 0x squared is negative 4x squared. Negative 3x plus 3x, in fact, is 0x's. I'm going to write it down. It helps. And bring down the negative 4. Okay. So, again, I just want to account for every single term at every single power. Even if there's none of it left, we still write 0x's. Okay, so x squared goes into negative 4x squared. We just need the negative 4 factor. So negative 4 times x squared is negative 4x squared. Negative 4 times 0x, 0 times that's 0x's. And negative 4 times 1 is negative 4. And when we subtract these, as you see, that's gone, that's 0, and that's 0. So now at the very end, when we're done and have nothing else to bring down, yes, 0x squared, yes, 0x, yes, 0, but all that is just the 0 remainder. Okay, so one more time, here is my answer. x squared minus 3x and minus 4. And then we'll be able to break this down further for other reasons in the next two sections. Okay.